Hey everybody, Bill Sky, the FORTRAN guy, and we're going to start talking about FORTRAN functions. Now, I'm going to split this video up into 3 different videos because functions can be done multiple ways in FORTRAN. It can be a little bit confusing, which is why I'm doing these videos. But the first thing we're going to look at is we're going to look at functions. A normal function that you would see like in another language like C, C++, Java, Python. Any of those type of languages, they pretty much do functions the same way, and that's what we're going to talk about here. However, there's another type of a function in FORTRAN called subroutines, and these were the type of functions that they had way back in FORTRAN 77, version 77. There's still a lot of FORTRAN code out there. I mean, billions of lines of FORTRAN code, and if you get a job working on stuff like this, you might see some of this older code. So you definitely want to see how to mess with subroutines. And then there's a third type of a function, which is a statement function. And a statement function we're going to do in the third video, and that's basically a function that's a single line of code. And it's degraded a bit. I haven't seen a lot of new code written in FORTRAN using statement functions. However, it is still in an awful lot of code out there. So let's go ahead and jump into functions and then watch the other 2 videos for subroutines and statement functions. Okay, so I'm going to be using the FORTRAN, the Intel FORTRAN compiler again, and I did find this worked with the GFORTRAN or the MSys GFORTRAN. So let's go ahead and just create a new project, and I'm going to call this one. First of all, let me make sure I've got the right. Oh, that's the wrong template. I got to get rid of that thing. Let me go ahead and just delete that. Okay. So let's go ahead and create a new project, and I'm going to call this one FORTRAN functions. Okay, now the first thing that we want to do is we want to create some variables. So I'm going to create some variables here that I'm going to use when I actually call the functions. So let's create a integer, a few integers, some very bad integer names, and now let's create an integer called parameter. Actually, it's not an integer called parameter. It's a parameter. It's an integer parameter. That's the same as a constant in C and C++. So a parameter. So if you say the data type, in this case integer, comma parameter, and then you give it a name, that is a constant in FORTRAN. I may have talked about that when I was talking about in other videos about creating variables and things like that. But string length is, in this case, is not a variable. It's a constant. So the way that that works is that the compiler, every time it sees the word string length, it's going to replace it with the number 80 and then continue the compilation. So it's not a variable. You can't change it. And now let's go ahead and create a string. And this is why I created the string length constant, or the parameter, is so wherever I have loops or anything like that where I'm going through the string, I can just use the string length constant, or the parameter, instead of actually having to type in 80. Why is that good? Because if I decide to make this 120, I only have to change it there and recompile. If I hard code 120 in multiple locations, it can create some problems. So that's why I'm doing that. Okay, so let's go ahead and let's set the vars. So source and again, I'm doing this the first time, and let's go ahead and make. Okay, oh, I redefined that, so that should be Z. There we go. And let's run it. Now, just to show you, I'm going to go down here in my code, and I'm going to say string length equals 99. So I'm going to show you how this is a constant, and it shows right here. This parameter constant, you can't change it again. So once it's set, you can't do it. Once it's created, you can't modify it. Just like any other type of a constant in a program. Okay. So let's call our first function. So let's do something very simple. And these are user-defined functions. So I'm going to say x equals print hello. Now I'm going to go ahead and save that and build it. And we have a problem. The compiler doesn't know what print hello is. And so let's take a close look at this. Print hello is the name of the function, and it has open and close parentheses here, and that's where arguments go. So if I want to send the function some data to have it process that data, which we'll do in a little while, that's where I would put that data inside of the parentheses. So I might do something like this, 10, 20. So I'm sending the number 10 and the number 20 to the function print hello in this case. But because this is our very first function, I want to keep it very, very simple. This function is going to return a value. That's what the assignment character is there for, and it's going to put it in X. So functions normally always return values. Subroutines don't have to return values, but functions pretty much do. So that's the actual call to the function. And because all this function is going to do is print hello, I'm not going to do much with it. I'm not going to do anything with the actual value it returns because it's not going to return anything. Okay, so right before the end program, I'm going to say contains. Now this is a statement in FORTRAN that says this main program contains other things. In this case, it's going to contain functions. So I'm going to create a function that's going to retain an integer called print hello. All that function is going to do is say print hello from print hello, and then I'm going to say print hello. This is going to look weird, equals 0, and then I'm going to say return. And then from there, I'm going to say end function print hello. Now this might look kind of weird. First of all, you've got the normal function definition, the definition line that says that this function is going to return an integer. This is a function named print hello, and it's going to take 0 arguments. It's going to take no parameters going to be sent to it. Then right here we have the code that's going to be executed in the function. In this case, it's just going to print to the standard output hello from print hello. But then this one looks kind of weird. What we're doing here is we're saying this is the return value. 0 is the value that we want to return to whoever called this function. So we say print hello equals 0. We actually put the name of the function there and then assign it a value. I know that looks kind of weird. In other languages, you would just say simply return 0. But in this case, this is how functions were defined or created in FORTRAN, where you say the function name equals 0, then you say return, and that's pretty common. And then here's a new one, end function print hello. Now, why do they have the end function print hello? Because in FORTRAN, you don't have open and closed curly brackets like you would have in C, C++, and Java when you create a block of code. So this is the block of code that is the function print hello. So let's go ahead and make that and see if everything's good. Run it. And there we go. Hello from print hello. So totally cool. You've written your very first function, and it's within the contain. So we're going to put all of that down here. We're going to put all of our functions inside of the contains. One other thing to notice there is that the function is not defined before the main part of the program. That's something weird. You can't do that in C and C++, but you can do it in FORTRAN. And so I like that. I like doing it that way. Okay. Now, one thing I don't have in my main program is I don't have a stop. I'd like to put a stop there. And all the stop does is it says, okay, that's the end of my FORTRAN code. Okay. Let's do another one. This time, let's create a function that is going to multiply some number by 2. Okay, so I'm going to have to send this function a number, and that function is going to do something very simple. It's going to multiply it by 2. So what I'm going to do is I'm going to say x equals, let's call it mult by 2, and I'm going to send a variable to that. Now I could have sent it a literal, or I could send it the actual variable, in this case the number 2, and then I'm just going to say print asterisk y multiplied by 2 is x. So the way that this is going to work is that I'm going to call the function multiply 2. I'm going to send it the variable y. In this case, it's going to have a value of 2. It's going to do the multiplication, and then it's going to return that multiplied value, and it's going to put it into the variable x, and then we're going to go ahead and print that information. Okay, so let's go ahead and do that. So now I'm going to say my function is going to return an integer, and the name of it is mult by 2, and I'm just going to give it some variable name. This is a local variable. I'm going to call it x. And then now I have to define what kind of a variable is that. In this case, it's going to be an integer. And then I'm going to say mult by 2 equals x times 2. Very strange looking. But that's how you write the code. So let's quickly look through this. Now I could have called this zzz if I want. So the argument or the variable that's being sent to the function can be any valid variable name. In this case, I called it zzz. Now, one thing that you would do in C and C++ and Java and other languages is you would possibly put the data type right here. Well, FORTRAN doesn't work that way. You can't do that. So once you have the variable zzz there, you have to say what kind of, to the compiler, what kind of a variable is that? In this case, it's an integer. And then you simply say the function name mult by 2 is equal to zzz, the local variable, times 2. And then you return, and that variable or that result is now put into the variable x in this case, because that's how we called it. Okay, let's go ahead and make it, and let's run it, and there we go. 2 multiplied by 2 is 4. Now, in a future video, I'm going to show you how to print things off to the a little bit better formatted. They're not so spread out like these. But for now, let's just go ahead and do it that way. Okay, so there we go. So now let's do another one. Let's do one where we say, I don't know, how do I want to say this? What function do I want to make next? Let's have a function that takes 2 arguments. So I'm going to say x equals power by 10, 5. Okay, so what I'm going to do here is I'm going to write a function called power by, and the first argument that I send the function is going to be the number that we want to raise to a certain power, and 5 is the power of that exponent. So in this case, this will be 10 to the 5th. So I believe that's 10,000. Or is it 100,000? I believe it's probably 100,000. Okay, so let's go ahead and write that function. Okay, so that function, again, that's going to return an integer. So I'm going to say integer function power by x, power by x comma y. Both of those are integers, but I'm going to create another variable that is going to be local only to this function. I can't access z outside of this function. If the z is not defined outside of the function, then you'll get a compiler error. But in this case, z is only for this function. And I'm going to do another one just called the power. Okay. I'm going to say the power equals x, and x is the number that has been sent to this function. So the power is equal to x. Then I'm going to say do z equals 2 to y. The power equals the power times x, and the do power by equals the power, and then I'm going to say return, and I'm going to say end function power by. All right, so let's look at this code a little bit closer. So I'm defining what are the 2 data types of the variables being sent to the function. In this case, they're both integers, x and y. I'm creating another variable which will only be available inside of this function called z, as well as an integer. And I'm going to create another variable called the power, that as well as an integer as well. Now, I just decided to do it that way. I don't like modifying variables that are actually sent to the function. I leave that to the function or the procedure or the set of code that's calling my function. So I created a thing called the power, and I assigned x to the power. Now what that does is that basically does our first multiplication. It just simply puts that in there. And so I don't start at 1, I start at 2. And y is the number, is the power of that we want to take. So I want to run through this, loop 4 times, not 5, because remember I called 10 comma 5. I want to do it 4 times. So we did x times 1, then x times x. So that's why we went ahead and did this. And then we have a loop that goes from 2 to y. And then I say the power equals the power times x, which is the 10, which is the original number we sent to it. I end the do loop, so this is going to execute 4 times. I'm going to then assign that mathematically calculated number, the power. I'm going to assign that as the return value to power by, and then return. Okay, now let's take a look and see if I printed anything. Okay, so I didn't print anything, so let's say 10. Yeah, so 10 raised to the power of 5 is x. All right, let's go ahead and make it. Let's run it. There we go. So 100,000. So 10 raised to the power of 5 is x. Now there's another way that you can do this, and I could do it. I could have done it up here as well. I could say print y multiplied by 2 is, instead of putting x, I could say mult by 2y. So I don't have to actually assign the return value to a variable. I can simply use it in a print function. I can do the same thing here. Print 10 raised to the power of 5. Let's say 3 is, and I can say power by 10 comma 3. So I actually use it inside the print. And there you go. So you can see 1,000 there. You can see the same number there for. I could have changed, instead of 20, y, I could have said 30. So I could send a literal to it. All right, looking pretty good. So multiple ways you can do this. Now, which way is better? Is this way better by doing it this way and then printing, or is this way better? Well, it all depends. If you're going to need that number, if you're going to need that product, if you're going to need the result of mult by 2 in more than one place in your program, assign it to a variable. That way you don't have to call the function again, unless you have to. So just assign it to a variable. That way you can just use x. You might want to, we're using x here too. If you want to save this, put it in a different variable. Why do it that way? It's going to improve the performance of your program because it's not constantly having to go back, grab that code, re-execute it, right? The data is just in the variable. So it all depends upon how you do that. All right, so that's multiple ways of doing it. Now you can do this with a double, you can do this with any type of a number, but you have to make sure that the function is going to define the argument that's being sent. It's going to define it as the correct data type. Okay? All right. So that is functions with numbers. Let's try a function with a string. How would you do that? So what I'm going to do is I'm going to say, what did I call it? I called it the string equals Bill Sky. And I would like to print the value of the string is, and this is mainly for debugging purposes, the string. Okay, now I'm going to say the string is equal to upper, the string length. So I'm going to create a function called toUpper that is going to take our string and convert all of the characters into uppercase. Now this is really important what we're going to be doing here, because I'm going to be showing you also in this video how to treat a string or character string in FORTRAN as an array of characters. All right, so there you go. So the string equals toUpper, the string length, and then let's go ahead and say print the uppercase value of the string is the string. Okay, now we can't really compile this yet because we don't have toUpper defined. So let's go ahead and now define toUpper. So let's do that right underneath the contains. It doesn't really matter. Okay, so this function, we're going to say function to upper. Now notice nothing is changing. Notice that I'm not specifying a data type here. So I'm going to say function to upper, the string, the length, and I'm going to say the result. This is another way of doing a function. The result is going to be returned, called return string. Okay, we're going to get into all what I'm doing here. Okay, so let's create an integer. And we're not actually creating an integer, we're simply defining that the length, and I didn't type this right, the length, the variable length is an integer. I'm going to also say that the string is a string of characters of length, the length. So you see where we're going with this? So this way that our function will be able to operate with any length string. Okay? All right. Now, what I want to do now is I would like to return a new string to the whoever called this function. So what I'm going to do is I'm going to say the length of the string, and that's the syntax to get the length of a string. I want to allocate that string, dynamically allocate it, and call the variable return string. So what are we doing here? We're allocating a variable called return string, and we're saying that it's going to be a character string of length equals to, we don't know yet. We're not really sure how long it's going to be. Okay? All right. And now I'm going to create another variable just so I can use it as a counter or whatever. Okay. So this is kind of like, this allocate right here is kind of like creating a pointer in C and C++. Okay, so now let's actually allocate the memory for our return string. So I'm going to say allocate a character string where the length is equal to the string, which is what was sent to our function, and I want to call it return string. So this is like a new. In C++. Or it might be like malloc in the C language. Now let's go ahead. I would like to actually start compiling to make sure I've got my code right. I think it's okay. I just don't think my code is complete yet. I haven't assigned it to it. So let's just go ahead and continue our coding and we'll see where we go. Okay, so we allocate the string. Now I'm going to create a loop. And the counter is going to be I. So I'm going to say, and that's why we allocated, or we created that integer up there. So we're going to say I equals 1 to the length. That's the value, that's the length of the string that we sent to this function. And we want to increment it by 1. I'm going to put an undo here so I don't forget. Okay. Now, what do I want to do? If it's lowercase, I want to change it to uppercase. If it's uppercase, I want to change it to lowercase. So what I'm going to do is I'm going to say if the string, and this is something new, we have a string here, and we're going to say from I to I. I is our counter. So what that means is it means take the character string called the string. I want to start at position I, which in this case is the first position in the string, and I want to go to the first position in the string. That means give me one character. Now when we increment through this do loop again, I will now be equal to 2. So it'll say 2:2, which means give me the second character up to and including the second character. So that's why we do that. So if the string of I, and we're going to use the C++ or C type nomenclature, is greater than or equal to A, and the string of I is less than or equal to lowercase z, we're looking to see if it's lowercase, then what I want to do, I'm going to say return string of I. Now return string is the newly allocated string. I'm going to say return string I is equal to a character which is an integer character of the string at I, minus 32. My goodness, what is this all about? So so let's go from left to right. So we're saying return string, which is the new string that we allocated memory for here, return string at the same position as we're on in the string. So in this case, 1, 1. So return string starting at 1, going to 1. I want that to be equal to a char, a character. But the character is created by asking the string, what is the integer value of the character that we're currently looking at? What is the integer value? If the integer value, or we're just going to get the integer value, I'll show you that in just a moment, we want to subtract 32 from that. I put 21, we're going to subtract 32. Now, what in the world is this integer character? I'm going to go into my browser here, and I'm going to take a look at AsciiTable.com, and let's take a look at a lowercase a. A lowercase a is actually stored in memory as the number 97. That's the integer value of the char. So we're going to take a lowercase a. So let's say it is. Let's say it's a lowercase a. The ichar function in FORTRAN, it says give me the integer value of that a, and that would be a 97. Then we say subtract 32 from that 97, and we get 65. So we're going to have the number 65. That's where the char function comes about, and that takes that number 65 and converts it to a char. And so that's what this line of code is doing right there. Wow, pretty cool actually. I'm going to say else. If it's not, I'm just going to say return. If it's not lowercase a to lowercase z, I'm going to say return string I is equal to the string I. I do not want to make any modifications to that character. And I'm going to say end if. Okay? Let's see if that now builds. Okay, we have a little problem here, so let's take a look. Let's figure out what our issue here is. I'm going to clear this, and I'm going to say make, and now we can go all the way to the top and see. Okay, so we've got a problem in line 50 on line 51. We have an end if. Oh yeah, that funny underscore character there. Okay, here we go. All right. So we've got a problem in line 41. So on line 41, we say char length equals null, comma. Oh, and not allocate, allocatable. I used the wrong keyword there. Colon, return string. So what we're saying is the allocatable verb or noun or whatever you want to call it, we want to say that this variable right here is allocatable as a character string. And we don't know what the length is just yet. And the reason we do that is because we're going to allocate it down here in our function code. Okay, so it's clear. Let's make it. Okay, good. So we only have one error now. Let's go down to 45. And it says, oh, I think the reason we've got this problem is I'm missing a parenthesis. Actually, let's see. So it says, oh, it's not length equals the string. It should be length equals the length. We use this argument, which is the actual string being sent, instead of that argument. Now, why are we going through all of this thing about allocating the memory? Because I don't want to change the original string. I don't want to change the string. I would like to just send back a string to whoever called this function. And that way, because that main function may not want me to change that string. There we go. Let's run it, and there we go. So the uppercase value of the string is Bill Sky. The value of the string is Bill Sky. All right, pretty cool. So that worked. Now, one thing I want to do now is I would like to now create a function called to lower. And you're going to see how very simple this is. So I created the toUpper function, and I'm going to create the toLower function. All right, so all I'm going to do here is I'm just going to take this code, change toUpper, and this is in the copy, to toLower. All right. And now instead of looking for lowercase a to lowercase z, I'm going to look for uppercase a to uppercase z. And instead of minus 32, I believe I'm going to put in there plus 32. Yep. And the reason again for that is that if I have an uppercase a, which has a value of 65, I want to convert that to a lowercase a. So I get the integer value of a, which is 65. I add 32 to it. That would give me 97. Then I want to use the char function to convert that 97 into a character, and I get the lowercase a. All right, I believe this might build the first time. Look at that. I'm going to run it, and there we go. So the value of the string is Bill Sky. The lowercase value of the string is Bill Sky. Now, one thing you might be asking yourself is, well, wait a minute. I thought the teacher said that the toUpper is not going to change our string because we allocated a different string here. Well, the reason why it did change is because we did the assignment. We said the string equals toUpper the string. What we could have done is I could have just called the function this way and not actually modify and here we go. So let's take a look at this code. The value of the string before I'll make it all upper is Bill Sky. The uppercase value of the string is uppercase Bill Sky. Then the next time we printed out the string, it was Bill Sky with lowercase characters in it because we didn't do the assignment. We didn't assign it to it. And then now the lowercase value of the string is Bill Sky and the program's ending. Pretty cool. Boy, a lot of stuff in this video. We talked about different kinds of functions. We talked about the contains class. A lot of information. It might be a good idea for you to go back and re-watch this. First of all, I'm wonderful to listen to, but it might be a good idea for you to go back and re-watch this and try it out step by step. Okay, introduction to functions in FORTRAN. Go crazy. Look over this video again, watch it as many times as you want, try different things out. If you're just watching the video and you're not trying it out, you're really, really cheating yourself. It's a really good idea to code and pause the video as you're coding, see what mistakes I made, find out what mistakes you're making, make modifications, and then move on. Next video is going to be on subroutines in FORTRAN, or it might be on inline functions or single command functions. We'll see, but see you at our next video.